parameters. So what flow and TypeScript don't do, we're filling in the hole there. And if you're interested, we can show you that a little bit later. So, but enough of that. What is fuzzing? Really, at its most basic level, the idea is to send an application unexpected input, and with the hopes of finding some kind of bug or other programming defect. And by unexpected input, I mean not expected by the developers. Weird input that just wasn't considered during the programming, but could trigger a bug. Any questions about this? Definitely stop me at any time when I'm going through this. Yeah. Yeah.
Is it just for JavaScript, or do you have something for other languages?
Yeah, so the question is it just for JavaScript or is it for other languages? I mean, fuzzing in general was originally done more on C++ and C programs, and I'll talk about that in a second, but more and more people are fuzzing other languages. And so tonight we're going to talk about fuzzing in general and then talk about fuzzing JavaScript specifically. And so this is kind of the most basic, simple algorithm that is fuzzing. It's a brute force technique. And the idea is to just hammer a program over and over and over again with weird input. Sort of step number one is important, like where do you get the input from? It can be totally random. It could be from a list of known weird input. It can actually otherwise be generated in a more intelligent manner based on previous fuzz runs. But the idea is to come up with something weird, one way or the other. And then step three is also important too. So fuzzing was originally done against C and C++ programs to get memory corruption bugs. And so there you're looking for a crash. Very easy to find, very noisy. Tonight we're going to talk about in JavaScript, trying to force unhandled exceptions. Mostly type errors, but it could be other runtime type errors too. And this is really a brute force technique. Do it lots and lots and lots of times until you get something. When I was fuzzing stuff on a laptop, it could take a week to really get a good fuzz run in. And we're talking about tens of millions of executions in some cases. So it really is kind of a brute force thing. So the history, quickly about the history of fuzz testing. Back in the punch card days, programmers that were really insistent on getting really clean, solid code would actually take punch cards out of the recycling bin, or maybe in those days more likely the trash, and run it as input to their program. So they'd run the program they're working on and say, oh, let's send it this totally random data from these punch cards we found. And it was a technique, it was fuzzing, they didn't call it that, but the idea was to find bugs. Then in 1998 at the University of Wisconsin, there was this computer science class, and they first used the term fuzzing. And so they were doing a project and they were doing fuzzing, and they were the first to ever use the term. More recently in 2013, some really amazing fuzzers came out, open source fuzzers, that were really good at finding security vulnerabilities, like AFL, also called American Fuzzy Lope. And it's found security vulnerabilities in literally every major open source project. And then really in the last couple of years, people have started writing fuzzers for other languages, not buffer overflows, not unmanaged memory, not memory corruption, but other languages, and found ways to fuzz them as well. So we're going to talk about JavaScript tonight, but there's also fuzzers available for Rust, Go, Python, and probably other languages too. So what's it good at, or why do it? I mean, when you write code, you write your unit tests too, and we all try to do our best to think of the edge cases, think of the corner cases, think of the weird stuff that could come in and cause a problem, and write a unit test for it. But it's really hard to think of all of them. As maybe we've seen, when you release the code and then a customer does something really weird and it shows a bug that you didn't know about. And so it can also, it can really be really good at finding these really weird corner edge cases, as well as static analysis tools. Also, they're really good. We'll talk about them in a second, but static analysis just examines the source code and tries to find patterns that might indicate bugs. Whereas fuzzing is dynamic analysis, it actually runs the code. And so it can find bugs that are missed by other tools. So here's another way to consider it. When you're running unit tests, you're checking the output. You have input, we should expect this output. If not, it's a failed test. With fuzzing, we check behavior. Did it crash or didn't it crash? Was there an unhandled exception or not? Or maybe other error conditions that we're concerned with. Okay, so that kind of like concludes what fuzzing is broadly. Any questions on any of that so far? Yeah.
I'm a little confused about the distinction between fuzzing and unit testing, because it seems like if you did a good unit test, maybe it would cover many of the scenarios you're talking about with fuzzing. How do you draw that distinction?
Yeah, I mean, it's, you know, hopefully that's the case. Like, hopefully, you know, you did cover every weird possible corner case in your unit tests. But it's just really hard for humans to be creative enough to think of everything. So the idea of fuzzing is we'll run it another 10 million times with all kinds of weird input, with the hope of finding tests that the unit tests, or finding bugs that the unit tests might have missed. Is that a little more clear?
So would you apply fuzzing to the unit tests also, as well as to the entire system?
I would say more like you use fuzzing in conjunction with unit tests. Like, definitely, you know, of course, keep doing them, but sort of what the new idea that's coming out a lot is that fuzzing should maybe be in your CI cycle as part of unit testing. When you do a push, let's say, also do a fuzz run. Yeah.
Yeah, possible that you will go into this later on, but how intelligent is that fuzzing? Because, you know, all the permutations, you know, they explode in the possible testing, especially when you already have taken care of the application that the input can only be a particular length.
Yeah.
So doing fuzzing with a length of +1, +2, +0, it doesn't matter.
Yeah.
So how intelligent is
that? It depends on the fuzzer, and so the fuzzers can vary quite a bit. I mean, the newer fuzzers, these open source fuzzers actually do coverage-based testing, and so they know what parts of the programs they've covered before, and they try to find new problems too. And so the very sophisticated new fuzzers actually handle a lot of what you're talking about. Like, they won't do +2, 3, 4, 5 if they didn't already get an error from a max length or something like that. And so, but actually, what I'm going to present tonight is actually fairly crude, and you know, we think it could still find quite a few bugs in it, but it really depends on the fuzzer to answer your question.
So you look at the source code? I have fuzzing.
There's multiple open source fuzzers available for various languages. Yeah. Yeah, in the back corner. Yeah. Thank you.
My question is kind of probably related. So how is the input generated per buzzer? Is it just random hits, or is there like an interface that like simulates a mouse click or a keyboard press, or how does the input from the buzzer get even programmed?
Yeah, so that can vary. It depends on what you're doing. And so I'm going to present essentially fuzzing JavaScript functions through their parameters. But you could also fuzz HTTP server by sending weird data in a GET or POST request. Or if you have a program that takes a file as input and does something with it, like parses it, you could send weird files to it over and over again. So it really depends on the language you're using and what you'd like to do. Yeah.
So as far as this, so fuzzing is attached to like a code kind of testing or using this. What about like this automatic UI script that kind of simulates clicks? Can you fuzz like by randomly clicking all over the place?
Yeah, so the question is, what about UI clicks or fuzzing UI? I'm really a server side guy, and so pretty much all the work I've done and most of the fuzzing work is mostly about backend stuff. Now you can definitely do that kind of UI work with something like headless Chrome or something along those lines. But I think most fuzzing so far has been mostly more about backend systems, or at least fuzzing functions directly. Yeah.
So on the same lines, so code coverage, you mentioned coverage. We try to have 100% coverage on our APIs, so you're going to find holes in that. And so, do you also provide maybe better code coverage? Like, is that perhaps?
Yeah, definitely. I mean, it's that's the idea of fuzzing, is essentially offer more coverage sort of for free, and it's coverage is a tough thing. Like, what do you really mean by it? And you can test every line of code, but that doesn't mean you really have coverage. And in fact, fuzzing really helps with that, because not only are you hitting hopefully hitting every line of code, but you're hitting it with lots of different input, which you're in some cases not as much so with unit tests. So that's how I kind of address that. I'm sorry?
Are there any other tools that do that with Fuzzing, or are you going to create that?
Yeah, we're working on creating that at Fuzz Station. That's part of what we're trying to do, yeah. Okay, so why fuzz JavaScript? So we've talked about fuzzing generally. Let's talk about JavaScript specifically. It's a dynamic language. So, and I mean that in a general sense. There's a lot that's not or can't be known very much at runtime. And so the idea is that maybe, static analysis is awesome. So you see ESLint here, our people, ESLint is awesome. It finds a lot of bugs. There's a security plugin for it that's really nice too. So, definitely everybody should run static analysis. But the reality is that there's bugs that static analysis just can't find, which fuzzing might be able to find. That's one thing. Another aspect of JavaScript is this. If your node server has an unhandled exception, it's gonna stop. And yeah, it'll get restarted, but that's still not great. Or maybe if there's an unhandled exception in a browser, that's also could be problematic for the end user. So these unhandled runtime exceptions in JavaScript are nice to get rid of. And so I did a quick study on GitHub, and I looked for repos with over 100 stars during the calendar year 2017. And I searched PRs and issues for these terms in the title, type error, syntax error, etc. And so this is what I found out. There are actually over 40,000 PRs and issues amongst that set. But type errors were common. Other errors are in there too. Range errors can even happen from off by one errors. Fuzzing can maybe find that. And so that's another thing. These errors do happen.
Is that across all languages, or is that
no, this was just JavaScript. Thank you. I forgot to mention that. So this is just JavaScript as well. So it's 2017 JavaScript repos with over 100 stars. And so I mentioned before, there's lots of, there's attack surface which you can fuzz. Tonight we're going to talk about fuzzing JavaScript functions directly via their parameters. And so that's the attack surface. And so you could fuzz every function you have in your project, but that might be overkill. There might be small functions, or as you said, things are really well tested, doesn't do much. But any more complex one, anything that does anything like parsing, or maybe if it's exported, it's part of a library. Those would be the functions I'd say to focus on. And so we're going to send it unexpected input. And so, that's the next step. And so for JavaScript, weird strings, that could be double byte characters, unprintable characters, half-width characters, maybe weird kinds of white space, maybe very, very long strings. Weird numbers could be not a number, a negative number, max value +1. Even just sending it all different types. So this is kind of like, it's inexpensive fuzzing. It's just send a number, a string. Expecting a string, send a number, but that can work sometimes. Then, of course, other problematic values. So where do we get this? Luckily, there's a cool GitHub project called Big List of Naughty Strings. And it has numbers in it too. So it also has big numbers and things like that. And so, so I've used this. And so this is a really easy way to fuzz your stuff. This is kind of the quick answer of how to get unexpected input in a pretty easy way. And I'm going to post this, this talk or these slides in the comments of the Meetup group later tonight. So if you'd like to check any of this stuff, it'll be available. Okay, so that's where you get our unexpected input from. What do we do with it? Generate a driver file. So this is kind of pseudocode. And so kind of for each function and for each string, just print it out. So you can do fuzzing by running stuff by, you could exec the program over and over again with your fuzzer. This is kind of a very simple way to write a fuzzer, which is just generate a driver file which calls the target function lots and lots of times with weird input as the argument. So here's an example of what I mean by a driver file. And so this could go, there could be lots of these. And so the idea is that you can write pretty easily a pretty simple fuzzer for JavaScript functions, which may flesh out some bugs. And so once you're generating a driver file like this, it's really just a matter of running it. and seeing what happens. And so, so my hope tonight is to say, okay, here's a pretty accessible and easy way that if you're interested, you could kind of write your own simple fuzzer for JavaScript. I'd like to conclude with a bug that I found using this technique. This is in a repo called Shields. Shields serves those badges you see on GitHub repos like 100% coverage, pass test, all that. It's a really cool project. And I was fuzzing this function called escape XML. And it expects a string. But actually really crude type fuzzing found a bug in it. If you send it a number or a Boolean, it would throw a type error, and that did crash this HTTP application. Not only that, but I did by hand, I actually was able to determine that you could do it from an untrusted position. You could do it with a URL. You could simply crash, anybody could crash the server with a URL. So I want to write technology that will figure that out automatically. I'm working on that to go from type error to say, okay, this could actually be done. So we're working on that, but this I did by hand. And so that's going to do it. Any questions? Really appreciate your time.
So is there any specific like library? Let's just assume that I'm publishing a library of helper functions for JavaScript, and I want to fuzz them all before I release it. Is there some sort of go-to default fuzzer package that I might go out and grab and use? And would it be kind of very straightforward for me to get, to pick a data set of fuzzing inputs from that? Or you didn't talk about any specific technology. So. Yeah,
there really isn't as much. Like it's new enough fuzzing things other than C and C++ that there doesn't exist that I'm aware of a JavaScript package or library specifically to do fuzzing. So, I'm hoping to present an idea where you could write it fairly easily. And I expect that might come out as well at some point too. But it is pretty new. So the answer is at this point there isn't anything quite like that.
Okay.
Yeah.
Do you have something like maybe some kind of like script like Python to scan your code, find the functions and generate those fast things?
Yeah, like a script to scan for the functions and then do this automatically. Yeah, so that's a great idea, and there's a couple of ways you could do that. I mean, I use recast a lot in JavaScript, so you can certainly use recast to go through and grab all the functions. Yeah, recast it's sort of like, it's like Babel, or it converts JavaScript to an abstract syntax tree object. And so once you have that, it's easy to pick out all the functions. It actually has its own helper functions to do that. And so, and there's other tools that are like recast. I think does Babel essentially do that, or can it? I think maybe Babel could do that, or ES-Prima. I think maybe ES-Prima is what I'm thinking about. So, so yeah, you could write a tool to find those functions and really script all of this.
This list you have this this list of funny things.
Yeah. Yeah, it's a big list of naughty strings. Yep. Yeah. So that's available on GitHub. Yeah. Yeah.
We're all trying to get from JavaScript to more typed languages like TypeScript.
Yeah.
So what would change if you would look at TypeScript instead of JavaScript?
Yeah.
It looks like 70% solve,
Yeah, it would. I mean, so if you had TypeScript, you could probably, those type errors would probably go away. And so, and that's actually what, this is just an idea. My company, what we're working on is we're working on type inference and handling things like that. Actually, so you might not even have to go to TypeScript, but yeah, that's TypeScript is addressing a really big problem because those type errors, as you see, there's 32,000 of them last year. So, yeah.
Any experience with hypothesis in Python?
No. Hypothesis in Python is that a fuzzer for Python? Or? Yeah. Thank you. No. I've not. I've heard there might be a couple others too, but I haven't got my hands on those. And I know there's fuzzers for Go and Rust and probably others as well, and probably more coming too.
What about functions that take not strings but strings and objects? Can you take objects?
Yeah, if a function takes an object instead of a string, that's a little trickier. I mean, if it's not the object it expects, you're gonna have problems, right? You're gonna have undefined. You're probably gonna have problems like, you try to access a property that doesn't exist in the function. So that's a little trickier to come up with the weird objects that are weird but not just completely wrong. So that'd be a little trickier to do. It probably could be done.
Well, thank the speaker.
Thank you.